This video is for Lesson 7-2, Proving Lines Are Parallel. Learning goals are to develop some theorems that we can use to show that lines are parallel and to determine whether lines are parallel. Number one, let's state the converse of each postulate or theorem. First, the same side interior angles theorem. So we need to think about this theorem from the last section and then switch the hypothesis and conclusion around. It would look something like this. If the same side interior angles are supplementary, then the lines crossed by the transversal are parallel. Question B, let's do the converse of the alternate interior angles theorem. It would look like this. If the alternate interior angles are congruent, then the lines crossed by the transversal are parallel. And question C, let's do the converse of the corresponding angles postulate. How about something like this? If the corresponding angles are congruent, then the lines crossed by the transversal are parallel. So these three statements are the converses of ones from the previous lesson, and we can use these as ways to figure out if lines are parallel. Matt is working on the blueprint for the new patio, as shown on the next page. Add information to the blueprint as you work through this lesson. To ensure that the rows of bricks will be parallel to the walkway, Matt extends the string line along the edge of the walkway and labels points X, A, and Y. He also labels points B, C, D, and E where additional string lines will cross the gas line. So let me show you that drawing. So here was the walkway, and then a string line is extended along the same direction as the walkway. Here was the gas line running vertically, and then through these other dots, we want to put additional string lines that all turn out to be perfectly parallel to this walkway. Okay, so back to the questions. Question 2A, use a protractor to measure angle HAX. So I've done that already. H to A to X, that turned out to be 65 degrees. Question B, locate a stake on the left edge of the patio at point P by drawing ray BP so that the measure of angle HBP is equal to the measure of angle HAX. Okay, so back to the drawing. Here's point B. What's going on is we want to locate a stake somewhere around this area and call it point P, and we want to position it so that when we put a piece of string through here, that this string turns out to be parallel to that string. So it said draw ray BP. So it would look like this, where this dot is point P. And we wanted this angle here to also be 65 degrees. Question C, locate a stake on the right edge of the patio at point J by extending ray BP in the opposite direction. So here we have ray BP. We just need to extend it in the opposite direction, staying parallel to this original string line. We're told to make that be point J. Question 3. For which converse from item 1 does your drawing from item 2 provide support and explain? I think it goes with number 1C, which was the one about corresponding angles, because angle HAX, that's this one here, and angle HBP, this one here, are corresponding angles, and they are congruent, and those lines look parallel. So that provides some visual support for our number 1C. Number 4, Matt realizes that he's not limited to using corresponding angles to draw parallel lines. Use a protractor to draw another parallel string through point C on the blueprint using alternate interior angles, and mark the angles used to draw this new parallel line. Well, the line might look like this. Going through point C and being careful to draw parallel to the original string line, which in turn was parallel to this string line. I'm going to call this Z just to give it some name. And again, we're making believe that we're doing this with an actual protractor tool, which I'm not able to easily put into the video. But if this angle here was 115 degrees, then if we used the protractor and measured an angle between here to here of 115 degrees, by keeping those alternate interior angles congruent, that's a way to make that line parallel to that line. Number 5, explain how this drawing provides support for the converse of the alternate interior angles theorem. Well, these angles that I had just written the 115s in are alternate interior angles, and they're congruent, and our rays appear to be parallel to the original ray. Now, number 6, use a protractor to draw another parallel string through point E using same side interior angles. Mark the angles that were used to draw this new parallel line. So here's point E. I want to draw a line through point E that is parallel to the other string lines. And just to call this something, let's call this point W. Now it said to draw this using same side interior angles. So the idea would be like if we knew that this angle here was 115 degrees, we could then put a protractor tool on the paper and measure this angle here, and as long as we make this 65 degrees, then this string will turn out to be parallel to this string. These are same side interior angles, and we want these to be supplementary in order for the lines to be parallel. So number 7, explain how the drawing shows support for the converse of the same side interior angles theorem. Those two angles are same side interior angles, and they are supplementary, and the rays appear to be parallel. So in this problem, we took advantage of those 3 statements we had created at the beginning to create some parallel lines by making sure that the different angle pairs had certain relationships. If corresponding angles were congruent, then we knew the lines were parallel. If the alternate interior angles were congruent, then we knew the lines were parallel. And if the same side interior angles were supplementary, then we knew that the lines were parallel. Number 8, Matt's assistant sets up 2 string lines as shown. And Matt finds that the measure of angle 2 is 63 degrees, and that the measure of angle 6 is 65 degrees. Explain how Matt can tell that the strings are not parallel. Well, angle 2 and angle 6 are corresponding angles. So they would be congruent if the string lines were parallel. So he can tell that his assistant screwed up. I guess that's why he's the assistant and not the boss. Here are some check your understanding questions, so I'll pause the video. In this lesson, we developed 3 theorems that can be used to show that lines are parallel. They involved corresponding angles, alternate interior angles, and same side interior angles. We also determined if lines are parallel. For example, that problem about Matt's assistant. We looked at those corresponding angles. They weren't congruent, and so we knew that the lines were not parallel.